chapter 4 of fluid mechanics, and here our first objective will be to do numericals on viscosity, medium plus high level, that is 2 star and 3 star, because 1 star we have completed in first classes. Okay, so without any delay, let's start. My first question is, I am writing down first question and then I will tell you the answer also. This is the question where you should always focus on. It's actually a 2 star question, and basically what is to be focused on: this part, this part, this part, this part, and and this part. Okay, so I will just draw the diagram. Having this one, okay. is the given thing in the question. Okay, so I think so this diagram is hopefully clear, though this circle is not accurate, but then also I will try to make it clear. And this is the direction as well. So this is the diagram, and I guess you have understood the question that it is written that a cylindrical shaft of 90 mm means this cylinder rotates about a vertical axis. This is the vertical axis. Wait, I will just show you the marker one. This is the shaft of 90 meter. This is a shaft which of 90 meter. This is this one. This red one. This red one I am referring to. This is the shaft. Okay, and it's a vertical axis. This is the vertical axis. This is the vertical axis, and a fixed cylinder of tube 50 centimeter 90 mm internal diameter. Okay, so this is 50 mm, and wait, let me see the question. 50 centimeter. I'm not getting so clear. It is 50 centimeter. Be careful with the units. See, again the units is changing. 50 centimeter and 95 mm. Okay, so here you can see that this is 50 centimeter. Tube of length, it is of length 50 centimeter. Okay, so this is 50 centimeter. And 95 mm internal diameter. This is 95. I told you this one is 95 mm. This green is already representing this green portion, this tube one, and the cylinder is represented in red. If the space between the tube and its lubricant of dynamic viscosity 2 points, means here we have filled a lubricant. Assume this as a lubricant. This pink one, you can see this is the lubricant, and this is filled by dynamic viscosity of 2 points. Okay, so this lubricant whose mu is 2 points is a lubricant. Okay, determine the power required to overcome the shaft if it is rotating at 240 rpm. See, it is already given in the question that this is rotating at 240 rpm. So I guess everything is written in the question, so I will rub this off to give you the solution of it. Okay, we will just interpret the figure and find out the answer. So first we all know that it is n is equal to 240. First of all, I will like to write the formula that is the main formula that we write. That is tau is equal to mu du by dy. We have this y, that is this, the clearance. Okay, so this clearance is nothing but 2.5 mm. And how to calculate this clearance, I will show you this. See, this is the thing we are required to calculate, this clearance part. This one arrow represents clearance. So how to calculate the clearance, I will show you. The shaft is of 95 mm and this is of 90 mm. So we can say that its diameter is 95 and its diameter is 90. It's a simple concept of this circle. Like, wait, I will show you in a better way. This green one represents the shaft, and this red one represents the cylinder. So we are required to find out this. and we have the diameter. We have the phi actually. We have the phi of this also, and we have the phi of this also. So what we will do, we will find out for this space. We don't have to do anything. We just have to write this like d2 minus d1. That is d2 minus d1 upon 2. Why 2? Because see, we are equal to find this one, so you can say this as r2 minus r1. Okay, and if we multiply it by 2, then what will happen? Both the sides multiply by 2 and divide by 2. Let's multiply by 2 and divide by 2. It is d2 minus d1 upon 2. So for finding the clearance, we will use the formula d2 minus d1 upon 2. It's very easy. You have to just find out this distance, and you can interpret by geometry also. So I will not go deep into this. It's just a basic concept. So let's focus what is given in the question. This y is 2.5 mm. We will take this care. This unit part we will look later on. We are just seeing what is given. N is 240 rpm. Mu is given straightforward, and that is given as 2 poise. I will tell you what the meaning of poise. It's just a 2 poise is just a CGS unit, and I will just tell you the what's its actual value. So we have this part, shear stress we don't have, and this also we don't have. Okay, but we have this RPM. So let's start up this question in a systematic manner. Solution. Given you know that first of all we need to find out a V, that is in the T is equal to tau is equal to mu du by dy, and here u and y are constant, so we can write this as mu u by y. Okay, so this is our formula, and for this we need to find out the velocity. This u represents the velocity. For that, first of all, let's find out the velocity. That how can we find out the velocity? We all know that since it is rotating angular, so we know that v is equal to omega r. I think so, no confusion. And this omega, what do you mean by omega? Means angular velocity. So you don't have to do anything. Omega means basically, like, I will give you a better example so that you will never forget it. That this omega is basically the angular one. Okay, so we will just write that how much it has traveled angularly, that is if it travels 2 pi in how much seconds, that is t. Okay, so we don't have to do anything, we have to just write it as 2 pi. Here we are considering s as the SI unit, and it is given rotation per minute. So consider this 240 rpm. What is 240 rpm? Rotation per minute. Okay, so that is 2 pi upon 60. And how many rotations? How many? This is for one rotation. That is, it will. I will explain you. Wait. In this way, you won't understand. I will explain you this detail that what is the omega and how to, and you will never forget this in your life. I assure you this. Assume this is a circle and it is moving. A particle A is just moving. Particle A is moving. Now what we have to do is, it has taken 60 seconds. Say it has taken t time, and it has covered 360 degree. So 360 degree is equal to t seconds. So 1 degree is equal to t upon 360, and you know that speed is equal to distance upon time. What I said, speed is equal to distance upon time. So there is no matter in this. What is there? It is the angular speed upon time. So this angular speed will be, omega will be, this distance means 2 pi r, means 2 pi. Here we are linear, means this we are considering the linear distance, that is this. We are considering this part. And when you talk of omega, we are just concerned about the angle. Say it has traveled, this was this theta. So this will be 2 pi upon t. This 2 pi represents 360 degree. Okay. So we have got this, that omega is equal to 2 pi upon t. What is this formula? You have to remember that is the speed is equal to distance upon time. So what is angular speed? Angular distance upon time. So angular distance would be on theta. So it is 360 degree, that is 2 pi. So our formula comes out to be omega is equal to V is equal to omega r. And one more reason that why V is equal to omega r, I shown you that omega is equal to 2 pi upon t, and this r is 2 pi r. So V, what is V? V is 2 pi r upon 60. So if you consider this is a circumference. So V is equal to 2 pi r upon 60. This is the linear velocity. This is the normal velocity, and this angular velocity omega is 2 pi upon 60. This angular, it is just consider about this theta. So if you multiply the radius, so it will be omega r. So never forget that why it is omega. I taught you that why V is equal to omega r. So you need not to learn anything about it. So V is equal to omega r. We can write this, and we can write that 2 pi upon t into n into r. I have written 2 pi into upon t because it will denote the time taken to cover the angular displacement, this t, and n is the number of rotation into r. And here, since it is in rpm, that is in minutes, so it will be so easy, 2 pi upon 60 into n into r. So V will be 2 pi n r, 2 pi n upon 60 into r. So let's calculate it out. Calculations will be 2 pi into 240 divided by 60 into r is, what is r here? 90 mm means 0.09 meter upon 2. And see, here we are concerned about the cylinders. Always read the question. Here we are just rotating the cylinder, so we will consider this 90 mm, not this 95 mm. So this r will be 0.09 upon 2. Don't confuse it. This is also 95, this is 90. No, it is 90 because here we are interested in the rotation of cylinder, and we are taking the rotation of cylinder only. So 90 mm will come into play. So we will get this answer as, after calculations, the answer would be 1.131 meter per second. Wait. (1.131 meter per second). First of all, we got a V. Now h, I told you h, we have, what we have to do for h, that is 95 minus 90. We don't need this anymore. So the find out quantity will be V is equal to 1.131 meter per second. H would be 95 minus 90 upon 2. Now I will use the notion for the formula so that you would get it in a better way. H is equal to 95 minus 90 upon 2. Now let's say this, that is for that 90. So we will get this T, that is Y. So Y will be 95 2.5 mm. Okay, and velocity gradient, that is du by dy. Okay, so here we can also write as du by dr, that we have already calculated, and this r is nothing but this y. Don't confuse with this one, forget this one. Du by dy we are going to calculate, so it will be v upon y, that is 1.131 upon 2.5 into 10 to the power minus 3. Remember it's in meters, so I have mm, so I have converted into meter, that is 2.5. That is 2.5 into 10 to the power minus 3 meter. That's why I put this the formula, and we get the du by dy is equal to 452.4 second inverse. It's just a unit of velocity gradient, nothing else. So we got our two terms, and now I will tell you what is the meaning of this poise. Most of them confused what is this poise. Okay, so poise is nothing but a CJS unit. Tau is equal to mu du by dr, and here mu is poise. So if you will calculate this mu, I have told you in dimensional analysis also that you can always calculate this, and this comes out to be, when mu is 2.0 poise, means we can write as, it's in CGS, so we can write this as 0.2 Newton per meter square dot seconds. So this will be 0.2 Newton per meter square, sorry, Newton per meter square will be pascals. Okay, so this is pascals dot second. So we have the value. Now we have to just substitute it. So we have found out V is equal to, these are things we find out. V is equal to 1.131 meter per second. Clearance, that is Y is equal to 2.5 meter mm, and here you can take it as H also, and this, it's just a symbol, don't get confused. This is just a clearance we have calculated out, and this du by dy we have calculated out, which turns out to be 0.2 p, sorry, this we have calculated out as 452.4 second inverse, and this poise, this is mu, is our 0.2 PA dot S. PA was nothing but, it is nothing but Newton per meter square. Nothing but Newton per meter square. So our answer would be tau is equal to mu du by dy. So tau is equal to mu, we have 0.2 into du by dy, that is velocity gradient we have calculated out to 452 seconds inverse. That will comes out to 90.48 pascals. But in question we have to find out the shear force as well, torque also and power also. So you are well familiar with the concept, so I will tell you again. Shear force is nothing but force shear stress into area, isn't it? Shear stress we have calculated out to be 90.48. I don't know why it is 90.48, and area it is area. Okay, now imagine that what will be the area. This cylinder is just covering, means this is the fluid, so its CSA means curved surface area will be the area, since its outer surface is only in contact. The outer surface of cylinder is in contact, not the inner surface. So it is just CSA, not TSA also, because the upper surface is also not in contact. So the curved surface area will be here the area. So we know that the curved surface area of cylinder is 2 pi RL. It is 2 pi RL. Okay, so it will be 90.48 into 2 pi. R is 0.09. This is right as this as 0.09 meter. This is 0.09 meter. 0.09 2 pi into 0.09 upon 2 into 0.5. This L, don't forget about this, 50 centimeter is equal to 0.5. From here we have put the 0.5. This is L actually. So our answers comes out to be 12.791 Newton. Okay, now we have to find out the torque. Find out torque. Basically torque is F dot R, and here that is F is F shear dot R, and F shear we have calculated previously only, that is 12.791 into R, that is 0.09 upon 2. This is the R, isn't it? We are concerned about the cylinder, and this is the diameter. Phi is equal to 90 meters, so R is equal to 45 mm. Okay, so it's just 0.09 into 2, and which comes out to be 0.5756 Newton meter. And now our power required is power is nothing but force into velocity. Remember this formula only, that's it. And this force you have calculated out to be Fs is 12.791. And velocity also you have calculated out to 1.131, which will come out to 14.5 watts. This is the primary way, and if you want to do it in terms of torque also, it is also easy. You don't have to do anything. Just what you have to do is power is equal to force into velocity. So what We don't have to do anything. We want to represent in terms of torque. What is torque? Force into radius. Okay, so just multiply this by radius. Force into radius into velocity. Now just F into R will be torque. Into velocity. Okay, and what is this T? We have already calculated out. There is nothing but 2 pi upon T. Pi upon T. So this 2 pi here T is 60. So this it is 2 pi upon 60. So this would be. So I have done a little mistake here. Sorry, I'm really sorry for what I have done. Wait, let's clear the mistake. Power is equal to force into velocity. This force, torque is equal to force into radius. So this force can be written as torque by radius. So this I will write as torque by radius and velocity. Torque by radius into velocity is the power. And this power, this torque upon radius, T upon R into 2 pi upon T. And here, since we are talking about RPM, it is 2 pi by 60. T upon R into 2 pi by 60. If you will do this also, then also you will get the answer. And also you can do like this, that if you multiply it by 2 and divide it by 2, so it will be pi dn upon 60 also. Anyways, if you don't remember anything, just do force into velocity and you have calculated the force and velocity. So you will get your answers 14.5. I will not make it complicated. 14.5 or the Fs you have calculated as Fs you have calculated out to 12.791. So it is just 12.791 into velocity which I have calculated first is 1.131 and it will comes out to be 14.5 watts. So this is a simple formula, no need to remember that. Now I will just clear the canvas. Okay, so I will again do an important question which has come in many exams also, AICT exams. So I will like to do this question. It is also a 2-star question. The question is as follows. So here is the question. It's a small question. Okay, it's small, fine. It is saying that two vertical plates are kept between a gap of 15 mm, and the gap is filled with glycerin. Means same that fluid one, that is gap is filled with glycerin, whose rho is given there 160 kg per meter cube, and dynamic viscosity is given in SI units, no issues. And 80 centimeter square and 3 mm thick steel means a structure, means a tube, means a rod like structure which is 3 mm thick and 80 centimeters square in this cross sectional, 110 Newton, weighing 110 is exactly midway in the glycerin filled gap. Okay, no issues. If it is required to pull the steel plate at a constant velocity of 50 centimeter per second, estimate the force required. Okay, so let's start off with this. First of all, I will like to draw the figure in front of you. So just note it down, this question. I will just draw the figure and it will be more clear. I will write all the given information. Okay. The assumption is given that resistance at the plate, means the rod which is there between the two pathways, is to be neglected. The frictional force is not to be taken into consideration. Okay, I will just draw this figure. Okay. students, let's start. I will just explain you the question what it is. This as per the question, this is a steel plate and it has this gap as 15 mm between them. Means this is 15, as you can see this is 15. This thickness is two vertical plates, that is two vertical plates, and this thickness is 15, that is mentioned in the question. And this gap is filled with glycerin, means this is the gap. You can see this blue one portion, this is filled with glycerin. Whose glycerin density is 1 to 60 kg per meter cube, and mu is equal to 1.5 meter square. So everything is in units, and 80 centimeters square and 3 mm thick. Okay, so this is 3 mm, 3 mm thick steel plate. This is the steel plate. I also mentioned this is steel plate. So its thickness is, oh, I'm really sorry, I mentioned the arrow now. Wait. Steel plate is this one. This is the steel plate. This outer surface is the steel plate, and this is the thickness of vertical plates. This is the vertical plate. To make you move here, this is the vertical plate, and we have all talked that it is 15 mm this and steel plate. Steel plate thickness is 3 mm. And this is the so since it's a covered glycerin, and this plate, this vertical plate, it will exert shear force due to this glycerin which is filled inside. So since it is going upwards, as you can see that it is moving upwards with 15, so Fs, that you can see, this Fs will act in downwards direction, and this is the weight. And one more thing which comes into play that we will talk later, point 3 with, but let's start with this question. This is the given quantity, and the solution would be thickness of glycerin layer. This is 15. So by the geometry, since it is the symmetrical one, I will provide this as a symmetrical line also. This is at the center. So if this is 15 mm, this is 15 mm total. Wait. This is 15 mm. This is 3 mm. This steel plate, this is 3 mm. And we need to calculate this. So by simple geometry, you can calculate it that 15, this is 15 minus 3 upon 2, since it is center. So this is 6 mm. Thickness of the glycerin layer is 6 mm. Means this layer is 6 mm. This one 6 mm thick. Now we have to calculate the shear force exerted on it. Shear force is nothing but force. Shear stress is force into, let's find out the shear stress first. So shear stress is nothing but, oh yeah, wait, shear issues. We have the formula first, that tau is equal to mu du by dy, that is mu u by y I will write, and here it is t, so I will write this as t. Since it's same as the formula, but here we are taking constant as u and y is as c. Here this is actually the y, this is replaced by t, and mu u, this is nothing but the velocity. This is the velocity, and everything is constant, so I have not put any du sign. And one more thing, Fs means the shear stress, we can write is a shear stress is equal to tau into area. So this tau is nothing but Fs is equal to tau is mu this is v, this velocity, so we can write this mu v into a. Fine, upon t. We have just put these terms, and it will comes out to be 2.8. Wait, so Fs would be light is still smaller because it is becoming large. Okay, so I will write like this, like we have got as the rate is wrong. This T is 6 mm. We have calculated this T to be 6 mm. Shear force is mu V by T. We know this. I have taught you how it has come. And Fs is, oh yeah, I don't know why it is creating so disturbance. Fs is tau into area. So it is just mu V A upon T. And you can see there are two places, one here and one here. So what we will do is total shear stress, total Fs will be 2 into mu VA upon T. Okay, so this is the formula, and now let us find out this what is it is. Now this we have got, the formula we have got is, the formula for Fs would be the total shear force will, the formula of total shear force will be total shear force is equal to 2A mu V upon T. Now area is 80 centimeter. 80 centimeter was given up with us, means 0.8 meter. So 0.8 into 0.8. Why 0.8 into 0.8? It has a square. It was written in question that it has a square cross section. Means this is actually, you can assume that it is dipped and it has a square cross section area. So I will just, the area which is in contact will be only the square section. So it will be 0.88 to 0.64 meter square. The weight we have given as, weight with us was given as weight of the steel plate. The steel plate. This was given as 110 Newton. The steel plate weight is 110 Newton. This is the steel plate, the black color portion. And the volume of plate is, volume is nothing but area, area into length. So easy. So area is 0.64 that we calculated out into length. This T, you can see this T. T is 3. And one more thing, you might have got confused at what we are actually calculating. Here we are just concerned about this area, this water, this I have calculated about this steel plate, this black color portion. I am referring to this steel plate, this black one, the plates which is covering the outside area. So I will now write the results as results. We have found out results are as follows. Result is Fs is equal to 2a mu v upon T. Weight of steel plate is 110 Newton. Area of steel plate is 0.64 meters square. Volume of steel plate volume of steel plate 0.00192 meter cube. So shear stress would be 2 into this formula. Area we know. Now we can just substitute this formula. This formula we are getting. This shear stress we are calculating. So Fs will be 2 into 0.64 into mu we have as 1.5 mentioned in the question. V, velocity. Velocity was given as 15 centimeter seconds, means 1.5 meter per second. It was given as 15 centimeter per second. See this. So I will just write as 1.5. Everything is given. Velocity is given, and then thickness. Thickness is 0.006. You can see this 6 mm means 0.006 meter. I am writing everything in SI units. This area we know, this and now. So Fs will come out to be shear force, total shear. Fs comes out to be Fs weight. This Fs comes out to be 48. Fine. Now, considering the upthrust, see this is the Fs, we got the Fs, but weight is also there, that is 110. That is, if you consider this point, like it will be something like this. 110 Newton is downwards. This Fs is also downwards, 48 Newton. So you must be thinking the answer is 158, but no, you have forgotten one thing. That is, this force is exists and this is Fb. That is the upthrust that you will study in next chapter. Fb is the upthrust. And how to calculate this upthrust? It is just based on the principle of buoyancy. So we have to now calculate upthrust. So Fb, this is buoyancy, is volume of the plate into density. This will give a mass, and I told you to always calculate volume. So this would be density into mass, and this is a G, means we got the weight. Since we are calculating about FB, you should never forget this. It is nothing but M into G, nothing. And M we have written as rho into V into G. This is the volume of the plate immersed, upthrust, and this is equal to the upthrust. This is the Archimedes principle which you will study in the next chapters, next upcoming chapters. I will teach you that also. So this FB will comes out to be, this FB is equal to weight of object immersed, submerged in liquid, weight of object displaced. So this will calculate out to be rho into G into volume, rho GV. Basically the formula of FB is rho GV, that is rho is 1260 into 9.81 into volume. Volume, remember we have calculated very before only, that is 0.00192. You remember that we have multiplied the thickness of the steel plate into the area and the cross section 0.64. You, I think so you remember that. So we have calculated the volume previously only, and it comes out to be 23.73 Newton. So the effective weight will be, now you know all the values. Now let's proceed on the final answer, how the final answers, you know all the values. So the force which is acting on it is W FB FS. I don't know the symbols, you will get it better, I guess. This W in downward direction, this FB this FS and this FS. We have calculated this value as 2FS, means total shear force. We have calculated out, we have this is acting upward direction, that is the upthrust, this is the upthrust, this is the upthrust, and this is the weight. So the values are as follows. Weight is 110. This we are considering as positive. The sign convention here is this as this direction we are considering positive, and this direction we are considering negative. Sign convention. Okay, so plus 110 plus minus this FB, you know this FB, minus FB we have calculated out to be 23.73, plus total shear force we have calculated before only and it was 48, isn't it? So your final answer after calculating would be 134.27 Newton. Okay, this is all about the medium difficulty level problems on the shear force. Now in next class we will study about few complicated problems and advanced level problems. That will not take much time, but it will enhance your skills and that. So next class is optional for those who are just limited to AICT, but those who are preparing for GATE and other examination, they are most welcomed in that. So our next class will be purely based on advanced concept as this. Okay, thank you and have a great day ahead. If you like, you may subscribe and like.